Hey, everybody. Okay. I need a link. I get a link. Hello, everybody. And let me see if I can, let's see. For some reason, my mouse is running really sluggishly today. I'm not sure if it's these headphones or not. All right, we'll see how this works. All right, there we go. And let me record and do all kinds of things. Boy, this is odd. Hope this is not unbearable. Oh, that's interesting. It is related to the Bluetooth. There we go. Look at my mouse now. Whew, much better. How's everybody doing today? Am I streaming? Am I live everywhere? Okay, that's good. I was trying to be streaming and running from 6 different places all at once, and it's always challenging. Simultaneously, so one thing I'm not simultaneously doing for you all is streaming on Twitch, but you get YouTube instead. That's a pretty reasonable accommodation, if you ask me. Okay, so yes. Since everything is available online, and if you watch the videos and so on, I do not do a really strict attendance with regards to the live meetings. Since I've set up the check-ins so that I'm going to be pretty strict about attending your check-ins. Other than perhaps today, because I think we still have enough intro material to go over things that we might not get to all the check-ins today. So I'm not going to be super strict with regards to people being at the lectures. If I see that you have never come to a lecture or you're really, at this, then I'll be concerned. Obviously today already a bunch of people looks like we don't quite have everybody here today, but if stuff is recorded and available, then we're all that would be fine. Okay. Yes. Are you okay? All right. I'll try to. The one caveat is sometimes check-ins may or may not happen based on what the material is. We may run a little bit long today, and if we do, it'll be recorded anyway, so you'll be good. So I'll come looking for you for the check-in, and if I don't find you, then by 4:20, if I don't find you by 4:20, that's on me. But if I come looking for you and you're not around, then that's on you. Okay, that's the way check-ins work. So if I'm late, then we can call it off. If you're not here, then I wonder why you're not here. So that's how that happens. Okay, so once again, just making sure that I am recording, I am streaming, and I am live. So once again, yes. It'll happen all the time. You just get used to it. Yep. I would say, at this point, because 2020 is what it is. I mean, the Unity 2020 is what it is. You're probably safe going ahead and upgrading, but it's just it'll continuously change. Usually, unless you're encountering lots of bugs or something, and there's some fix, then don't worry. I wouldn't jump to a new version necessarily. So, so speaking of Unity, Programming in Unity again. So we had sort of left off. We were talking about C#, and we'd introduced a bunch of topics and kind of gone through with our program here, where we had created some text buttons and we had some activity based on there. And our code so far has been, so-so, we'll call it. There was some discussion, how many if else statements can we nest and be weird, and could you potentially do it in fewer? Obviously, we have an if and an else if and an else if and an else if here. There are lots of ways to be quicker than that. I won't worry about that. But the one question was like, well, should I be optimizing my code? And right now, we want to code for clarity for the most part, especially in cases like this where a button being pressed. The limiting factor is, of course, how quickly can the user press a button? How often is the user going to press a button? These days, game systems, game consoles, computers, and so on are capable of billions and billions of operations per second, and they certainly can handle a little bit of inefficiency when it comes to something that happens once every second or so. So I'm not too concerned about how efficient my button click kind of code is. Other code that gets called every frame or on every object on every frame, that's going to happen a lot more often. And that's where I'm going to start to be concerned about efficiency. Okay, because it is a real-time process. Like I mentioned, one of the earlier lectures, that's the big difference about game programming versus most other types of programming, is that efficiency and real-time and interactivity is kind of at the core of what we do. Code always wants to run reasonably well and efficiently, but it's important to us as game developers and in game programming. But we'll do it when it's important. Other times we won't be quite as caught up in it if we can be, use certain types of code to be more clear about what's going on. We may err on the side of readability for now, as opposed to squeezing every little bit of efficiency out of code. Now, believe me, I'm no stranger to writing assembly language and as necessary, and squeezing every drop out of a piece of code. It's a lot of fun. I enjoy doing that sort of thing, but I'm not going to do it for we're not necessary at this point. Okay. So that having been said, so we have our project. We have here, hopefully most of you have been following along, and you also have a set of buttons, a basic game manager script that reacts to those buttons, changes some text in another object, and you've got some logic in your code. You hopefully are familiar with a couple of different variable types, like integers and floating point numbers. Floating point numbers when we need to use decimals, fractional kind of decimal points. Integers when we have something that's an absolute, it's 1, 2, 3, Monday, Tuesday, Wednesday, things that have no in-between parts. Don't worry about those. Doesn't mean we can't do math on them, but math is slightly different. When you're talking about integers, right? If you're talking about integers and I say 3 divided by 2, what do I get when I'm talking about integers? Does anyone want to guess on that one? Somebody go ahead and type that into the 2020 fall. 3 divided by 2 in integer math. What is that? Probably 1, right? We can't be 1.5 when we're integers. Can't be 1.5. There is no integer 1.5. If I have integers 3 divided by 2, it rounds off the remainders. That's the big difference between integer math and floating point and double point math, right? So it would round down in that case. 3 divided by 2, we're going to get 1. No, there's no or. It's going to give us 1. So it's going to round down. All right. So be on the lookout for that. All right. There are ways to, keep that in mind and get better precision and so on. If you want to be, clever, but by default, you're going to end up chopping off the precision. All right. So we'll leave that for now. Remember that, because when you're trying to figure out, okay, am I in the middle of the screen or am I moving along smoothly? Like if you want smooth motion, you may need floating point or, floating point numbers so that you can, be in between 1 and 2, right? You're not either on 1 or on 2, you can do that sort of thing. All right. So let's see. I want to find the right. Where did it go? I could have sworn it was here. There. Okay. Back to programming in Unity. For now, we went through a bunch of things, and this is now, it's available. It's on LMS in the content folder there. There's a content folder. There's a lecture notes folder. This is available there, both as a PDF file if you want to download it, or a Google Doc if you want to just take a look at it. So I'm going to jump to where we were. We had just gotten through. We'd done basic if else, right? We had done some basic compound operator sort of thing. So if I said x plus equals 5, it would add 5 to x, that sort of thing. We were using incrementers, like saying x plus plus is equal to x plus 1, x equals x plus 1, that sort of thing. So in our code here, where we were incrementing y, or incrementing x, or decrementing y, or decrementing x. And let me blow this up a little bit for you here. There we go. All right. So this is the same as player y equals player y minus 1. Okay. That's the same. You feel free to use either one of those. Don't use them both, or else you'll be subtracting 2, which, well, unless you want to do that. So, but that's the sort of thing. We have lots and lots of ways to do different things to our variables here. And if else, so what happens here, it says, if this is true, and the moment that is true, it doesn't do any of these other things, right? So even though this may seem like, oh, is it going to check 4 times? It's only going to check 4 times if these things start failing, right? If this fails, then it'll check this. If this fails, then it'll check this, and so on, right? You may even have, if you wanted to be, if you knew that it was absolutely positively going to be one of these 4 things, 0, 1, 2, or 3, right? There's never 4. You could even eliminate this, because you know, if it got here, it wasn't these other 3, so therefore it must be this last one, right? I don't know. I'm kind of hung up on the if things, and someone had brought it up in the Discord. So it goes to say, if you want to talk about something, get me excited about something, mention Discord, and we can spend way too much time on that. But anyway, that is that code, right? Ifs are your friend. Ifs are the basic unit that we're going to use for logic, right? You can do things like say, okay, the player is going to react in certain ways, or a response is going to be, for example, I can set a Boolean, which is a true-false value. I'm going to have a Boolean for night. So during the game, is it night? And maybe that's based on a certain amount of time passing or something like that. I said night equals false. And then I can have some checks in here. And this is toy code, so it's not the most exciting code in the world, but it says if night, so if it is night, if night is true, print it's night. Otherwise, print, what are you worried about? Because this is a vampire game. It's not night. Vampires don't come out at night. Nothing to worry about, right? So there's our quick if else. Now, how this snuck into this particular slide, I don't know. I'm going to leave this out. We're not going to. So if you get confused by this one, fields versus properties, get and set accessors, that shouldn't be in here. That's a more advanced concept that we'll kind of leave out for now. Come back to that one. So here we are really today, part 2. All right. Conditionals, or more conditionals, and loops. Now, loops are also your friends, and other conditionals are your friends. Ifs are, of course, the most basic flexible conditionals in C#. The else is optional. You can just say, if this, then do that. Or if this, boom, that needs to happen. You don't have to have an else case, right? So you can also have lots of ifs. You can use else with more if statements. So there is no real else if. Some languages have explicitly an else if, which jam together one word. But really, we in C#, we have just if and else. If it just so happens after that we have another if, it all works together. But there is no else if, right? There's if and else. You can also nest them. So you can have ifs inside of ifs. So if an if, and you have another if inside, if night, and then you have some code inside, and you said if vampire, you have some more code inside there. So you basically said, okay, if night is true, all right, now start going in here. Then if the vampire is near, that's an and, right? Because we had, the first one had to be true in order to get into this loop or into this code. And then the second one has to be true in order to get into that code. So both of those have to be true, which is that and condition that we talked about last time, right? So this is how we form these sort of more complex relational operations, even just using combinations of if and else. So here's the example, a little bit weird. If this first condition, then run this code in here, all right? And if I then said else if condition 2, that logic actually is, this is what it represents. It says, basically, this code in here is only run if condition 1 was false, because it didn't happen. This didn't happen, so that means condition 1 was false, so this happened. And condition 2 is true. All right, so that's the effect of this if and else if. It forms an and that way. So it forms if this, else if this, it forms an and of the opposite of that one, right? Of the false with this true. And you could even go further to say, okay, have another else. So what's happening now? It's saying, okay, if this was false and this was false, then run this code, right? Run if both conditions false. And then run, you have this nested if, which isn't an else if, because this is inside this code block here. This is an independent if, but it is a nested if that's only occurring inside this other piece. All right. So even with if and else, you can form these more complex relational operators, the logical operators of and or and so on and so on, right? Yes. No. Well, here, this would be, you're asking about like this, why is this particular code like this if inside here? Okay, imagine I was to say something like this. Right. So this bit of code here might need to run if these two are false. And then I might have this additional thing that needs to happen if these two things are false. Right? So if there was no other code here, right? If there's nothing outside of here, then this could have been, whoops, let me get rid of this. This could have been like that. You know, that code. If only this code were happening, then I would construct it that way. But you can do things like this, where other code is potentially going on there as well. That's why you would nest an if as opposed to just having another if else kind of thing, or else if. Does that make sense? Okay. So you can have ifs inside of code blocks for that purpose. You know, this one is sort of independent of, it's not only, or the stuff that happens in here between here and here isn't only dependent on that, which is why we make that an independent bit of an independent conditional there. Okay. But that's a good catch. That was a good question. I like that one. leave that in my edited version now. So that's, in this case, that's why. Continuous improvement to the course here. All right. Now, you might be saying to yourself, ifs, they start to look a little complicated. They start to look a little bit unwieldy if you have to have this kind of construction over and over again, and there's potentially some kind of weird things, and you have these, check this condition, then check this condition. There are other constructs that we can use that are a little bit more purpose built for some of these things. And specifically, like maybe you have a key press or something that happens, or maybe you can encounter a monster that's any number of different types of monsters, right? It could be any key on the keyboard. It could be Frankenstein. It could be the mummy. It could be the vampire. It could be a werewolf, whatever. And you don't want to say, if monster equals werewolf, do this. If monster equals vampire, do that. If, maybe that's what you want to have happen, but all those ifs become painful. We have another construct called a switch statement. And the switch statement allows us to basically say, compare some integer, consider some number, and then run code dependent on what that number is equal to, right? So it's an alternative to several if statements if you're switching on sort of the same variable. They all depend on the same variable, right? They're all that monster type or key press. We have all these different conditionals depending on that one number, right? You can compare for equality. It's only a comparison for equality, and you can only compare a single variable against literals, right? You can't have things that are calculated in here when it comes to the thing you're comparing to, right? So in this case, I'm going to say, okay, integer num, and somehow that could be monster type equals vampire. So down here, this code here would basically be we'll call it vampire code. And this would be take the vampire. Like that. Okay, what break is for is the end of that particular chunk of code. Because what you can do if you're not careful, if the case has no body, execution falls through to the next case. Otherwise, you get a compiler error. So, for example, if the same thing, like say you had orcs and goblins, and you wanted the same chunk of code to run for either orcs or goblins, I might have this sort of thing where, whoops, case 5, case 6, and then a break. So it would run the code in here before that break for both cases, 5 and 6. I hate when it capitalizes for me there. But the break tells it where to stop running, right? Where to hop out. Now you could even do things like say, if such and such break, and it'll break out as well. So the break is where it says, okay, stop processing. And it's most handy in situations like this where you want to have the same thing for multiple types. Like say you have, you allow the player to use WASD keys, but you also allow the player to use up arrow, down arrow, sideways arrows, right? So you could have key codes W and up arrow do the same thing. And then you have a break after, you don't have a break before the first one, but you do have a break at the end. But you do have to make sure that if the case has no body, it falls through. But if I did something like this in between those two, it doesn't like that. Some other programming languages don't mind and allow you to do that, but C# gets upset when you do that. So I've overcomplicated my case statement here, but it is a convenient way to do things like this code in here. Let's take a look now. This is one way if I wanted to get rid of the if statement. And I hadn't even thought about it. This wasn't the version I was thinking of. But how would I do it? I would say switch ordinal. And I'm going to go ahead and format that out like this. And I would say case 0, player y++ break. Case, why is it complaining? Did I do something wrong? Okay. I'm just going to put a default at the end here. It's because there was no final break. So I'm going to go ahead and create a default case just so it's not going to complain as I go along here. So notice now I have no errors because I gave it a default at the end. But I go through now. So case 0, player y++. Case 1 is player x++. Break. Case 2 is player y-. And case 3 is player x-. Okay. So that is accomplishing the same thing without this else if thing. Now, I'd argue this is cleaner than the other one because it's obvious what's going on. And if I wanted to add another case, it's easy enough to add it here. All right. So I'm going to go ahead and I'm going to delete that one. Brutal. Right. So if it's 0, I do this. If it's 1, do that. Now, internally, you might be asking yourself, well, what is it? How does that work? Is it, is that going to be wind up, is that comparing each one of those? And is it going to be as efficient as the ifs and so on? Internally, compiler design is a task for another course, but it can do all sorts of clever things given this sort of structure that can actually create tables and jump tables and things like that to run more efficiently than if we actually had coded up as a bunch of if statements here. So it's a cool construct. I like it. So that's a good example of a switch case statement. All right. Any questions on that? Go ahead and type anywhere if you need to. I think I'm still in fall 2020. Yeah. Okay. So the next big one is while and do while loops. Okay, so say you have something that you want to have happen over and over and over again. So you want it repeated, right? Say you have a dozen enemies on the screen, and for each of the enemies, you want to check something about them, or you want to blow them all up because they're all within the blast radius, or you want them all to move one at a time, or whatever reason. Oh, do we have time for can I let my cat out? I'll introduce you to my cat. I'm wireless here. Let me introduce you to Callie. Oh, she just wants to run out. So I'll be right back. Sorry about that. She is trained to only. She has trained herself that she has to go outside to do her business. So I don't want her to explode or anything like that. Exploding cat would be terrible. Okay, gave you a moment to digest the while, or no, we haven't gotten to the while and do while loops. We're about to be there. Let me check my time. It is 3 o'clock, which means, let me see. We aren't quite into I think we're going to continue on probably check-in lists today as well. So it'll be all right. So while and do while loops. If you want to have something happen over and over again, are we all back? Am I still? Okay, it looks like my volume is there. Okay. So if you want to have something happen some number of times or repeatedly, that's where you want to use while and do while loops, or their close cousin, the for loop. But we'll get into that in just a second. So the idea with a while and do while loop is that you want to execute the body of a loop repeatedly so long as the condition contained within the while is true. Okay. So you might have something like, while the players on the screen do this, or while enemies is greater than 12 do that, right? So according to some condition, go through this many times. Now, of course, you've probably heard of the term infinite loop. And the while and do while loops are the ones that are typically the most fraught with the potential for being infinite loops, because you are checking this condition. And if you're not careful and that condition is never met, this is when you run into that. This is when you run into the infinite loop problem. And in a lot of things like game engines, they're already designed around loops. Like you'll notice in Unity, we had this update loop that got called over and over and over again every frame. So there's already a loop going on outside. So the question is, will we be, if we do another while loop inside the other loop, then we'll potentially get stuck in this loop and never get to the outside loop. So you have to be careful about while and do while loops. All right. I just noticed someone did ask about the project. Are we required to use these buttons for the project? Yes, you have to use, well, you can modify them a bit, but you have to use UI button elements for the project. Yes. And other people who joined in late, the check-ins so basically, since we haven't really started doing the check-ins, it'll just be like the next it'll be an even week. So we'll just start even week. So everyone who had it this week, don't worry, you'll have it when you have it, but we're just going to have rotated. We'll pushed it. We're not pushed, but we'll kind of still having even and odd weeks. We just missed the first 2 weeks first. We'll get there. I'll email you. I'll let you know. We'll work it out. So let's get back to this one. So this loop, for example, would run over and over and over again, printing out the health of the player as long as the player was alive. And every iteration in the loop, we would be decrementing the health of the player, perhaps, right? So we would say, okay, in here, if health eventually hits 0, which it will, because this loop will happen over and over again, eventually health will get to be 0 because it's decrementing. And when it does, is alive is going to be set to false. And then this will be false and will fall out of the loop. The reason we got into the loop in the first place is because we had set is alive to true. Now, I'm going to go ahead and run that in Unity. Now, the question is, where is a good place to run that as a demonstration? So just for this purpose, the game manager code here, I haven't really been using the hello world piece of it much, but I'm going to put this code in the hello world because that's just going to execute and then this code will run. Okay. So let's run this code. Format it a little bit differently. And so let's see. Get all the bugs out here. And that should not be a capital. This is all the bad formatting from slides, but and these are the wrong types of quotes. The type of quotes you use is important. Okay. In your code, we just want plain double quotes. Sometimes if you're copying and pasting from other places, it will use fancy fonts and other quotes and do odd things. So let's just look at this one now that it's running. So we set alive to true. We set health to 10. We now have a loop that will subtract health each time through. And eventually, when that hits 0, it will set is alive to false and fall through. So I'm going to put and this is a bit of code that you'd really never do something this way. In Unity, this is an odd way to do it, but it's just a playground for now. So let's go over here, play, and if I look at the console, we'll see the result. So, ignoring the bolt issue here, we had hello world printed, and then we saw health start off, and immediately health was decremented by 1 in this code. Whoops, there we go. So health is decremented by 1, making it 9. This code never runs, but this code does. So it prints out health is 9, right? And then the loop runs again, subtracts 1, runs again, gets 8, subtracts 1, again, gets 7, 6, 5, 4, 3, 2, 1, right? So the last time through, this has been decremented to the point where it's 1. It comes in here, right? So the last time this was printed, 1 comes in, health minus minus, hits 0. This code gets called, is alive is set to false. Then this code does not happen. And then the loop is checked and the loop ends and the player dies. Okay. So a simple while loop there, right? Most of the time you're going to see it like if you needed to spawn a certain number of zombies or initialize a certain number of objects or set up, things. That's when you're going to use this up here. Doing something that's based on kind of printing out things for the user. This is pretty unusual code in here from a Unity perspective. But let's look again at our sample here. Now, so if the player died and we want to bring the player back to life, and we want to have a do while loop. Now, the only reason to choose sort of between a do while loop and a while loop is sort of if you know for sure, it is sort of an optimization. If you know for sure that you want to run at least once, you can use a do while loop, right? So the do, everything will happen in here at least once, and then it will check if you should move on, right? Otherwise, it's very, very similar. It's just checking the condition at the end of the loop. And unless there's any specific questions about that, I'm not going to do the cut and paste of that one. Just get into formatting and things. Does that make sense for everybody? Please shout out in the either in the voice or in the comments. All right. Next off, another type of loop. And there's actually 2 versions of this loop. This loop is the for loop. And for is more a iteration type loop. You can use it. You can actually create while loops using for loops if you wanted to get clever. So you'll probably use for loops more than you use while and do while loops. They're a little bit more. They have a little bit, a few more features that are optimized for iterating over things. Right. So for is usually used for repeating something a specific number of times. Like, again, if you said, okay, I want to spawn 10 enemies, you would probably use a for loop and make the conditions of the for loop be that it's iterating over something 10 times, 10 enemies. It is similar to a while loop, but it is more self-contained. If we did something like this weird looking for, and you'll see these 2 semicolons here. Normally you have a setup, a condition, and a post section, the iteration section. So normally a for loop is going to look a little bit more like this, where you have some initial condition you're going to set up, or an assignment. So you see this a lot. For int I equals 0, that's the starting condition, or the starting assignment. And then you run this loop until I is greater than. So as long as this is happening, so sort of the while part, right? I is less than 10. And then this is what you do after each iteration. So it's got you think of it as sort of having its own little program that decides how that loop gets run over and over again. So this is going to get run 10 times. It's going to go from 0 through 9. And the 10th one is the one where it bails out. Notice it says I less than 10. So it's not going to run if I is equal to 10. Right? And this one I will copy and paste, so you can see that run. And of course, it had those bad quotes. And what's it complaining about? Local variable I. Somewhere I broke. Oh. A typo. So if I come in here now, back to Unity, clear, and we'll rerun it. Thankfully, scripts aren't lost if I stop and restart. If I'd changed other things about that object, it would have been lost by this stop and restart here. But you'll see we did the while loop up here. The player died. And then my other loop that iterates between 0 and 9 got executed. Okay. So there's a quick example of a for loop. All right. Any questions about for loops or while loops or do while loops? Cool. For each. Now, for each is something that's more specific to the language and the way that C# works, and some specific things that we're going to use in C#. And it's going to be really, really useful inside of Unity, where perhaps you need to iterate through a collection of objects. Like, again, I keep mentioning about, oh, enemies on the screen or the monsters or something like that. And you want to do some sort of processing to say, okay, did I collide with any of the other cars on the track? So you want to do something for each of the cars on the track. That's where it got the name, for each. So if you want to iterate through all the members of a collection of things, so if you have an array or you have a list, then you can iterate through, you can process through all of the things that are in that compound, or that collection of data, right? The collection of those objects. So for example, if I had a list of strings that happen to contain all the names of the players, and don't worry about the list syntax just now, we're going to do collections in a subsequent lecture. But if I wanted to go through each of them, I could say for each, and then I would declare a temporary variable for each p name. I'm going to call the player name here in player names, and player names is this list up here. So I come up with a temporary player name here, and I say for each of those names in player names, then process whatever I need to, So if the bomb went off and I wanted to decrement the health of everything else on the screen, I would say for each player object foo in damageable objects, because that's my list of damageable objects. I would then say, okay, damageable object, run the script on it or something like that. All right, so to iterate over collections of objects. All right. Now we saw break before. Break was able to break us out of the switch statement, but break can also be used to break out of a loop. So if you have a for loop or you have a while loop, you can use break to cause it to immediately exit the loop. So for example, if you wanted to stop, if you found a certain value as you're going through all of these elements in this list, you might say, if it hits that value, print that you found it, and then break. And that breaks out of that for each. But you also have this, if you don't want to stop, but you want to do something special based on finding something, you can use continue. Continue stops the current iteration, but continues executing the loop, right? So perhaps you only want to iterate, or you only want to process odd numbers, right? We use this to see, is there a remainder? If there is no remainder, we use this continue within the loop that says, okay, go to the next iteration of the loop without processing. Now, the iteration of the loop, that means, you know, the instance, the body of the loop there. That's when I say iterate. Iterate is always part of some process that's getting run over and over again. You know, one unit of operation of that loop is called an iteration. Okay. So that was a big chunk of the structure of the language of C#, kind of the basics. And it's kind of the very C-ish version of C#. We're not getting into things yet like all of the object-oriented extensions and inheritance and polymorphism and all those sorts of things. But this is the basics of it. This is the you know, kind of the what is it, the nut of the problem, the core of what you need for this first project, and certainly for a lot of the projects going forward. Once you get these basic concepts, you're going to be in pretty good shape. So at this point, I'm going to try to introduce a little bit of the contrast, which is of course going to be bolt. And brace yourselves. This is the first time we're putting bolt into things, and I'm going to try to just dive right in, and we'll see how it goes. Does anyone have any questions before I do? Because who knows? Everything could blow up in a moment. All right. Maybe I'll do this before diving too much into bolt. We'll come to back to our project here again. Now, once again, if I run and I press up and down, you'll see I've got this printing values on the screen, and it only lets me go a certain number. It's supposed to only let me go. Okay, it only lets Y go from 0 to 12, and then it hits a wall, right? Sort of what happened there. So for those of you who have read ahead or read back and said, okay, let's talk about the homework, the project. The idea with this is that somehow we are controlling a player moving around in the world. So I'm going to go ahead and get rid of all this junk code we don't need anymore. And so the player is moving around, but the player somehow hit that edge, right? We had this conditional here where we said, if the player's X exceeded 12, then the player hit the wall. Else, if the player X was less than 0, it also hit a wall, right? So instead of just stopping it there, we want to do something. We want to say, the player bumped into the wall. We want to have an action happen, perhaps, right? So let's do something. Let's actually make something interesting happen in our game. So I'm going to have a Boolean called hit wall. And I'm going to say hit wall is false. Okay. So for starters, hit wall is false. And if the player is trying to go beyond 12, that means hit wall equals true. And if the player went less than 0, hit wall equals true. Okay, so now I know the player hit a wall. So the question is, what am I going to do based on that? Now, normally, this is the player. I'm just printing out its location. But maybe instead of that, I want to have something special that says, if hit wall, do something, else, do something different. And that might very well be this message here. So if the player didn't hit the wall, I just print out this message. And if the player did hit the wall, I would say main message ref, and I could do all of this stuff. I'm just going to cut and paste here. And I'll have a special message. You hit a wall. So I have now a condition. I have a, if I hit the wall here, I'm going to print something different for the player. I'm going to go ahead and put that right there. I don't know. You like that? Yeah. So let's go ahead and go back to Unity and play the game. And now I hit a wall. Can you hopefully read that? All right. And keep moving in the opposite direction, and I hit a wall. 12, boom. So it's actually at 13, it sort of hits the wall. It lets me go to 12. 12 is within the room, and 0 is within the room. Interesting, right? A little bit of a wacky behavior. I'm going to fix that up later. So now I'm communicating with the player, and if you've read the description of the project, we want to make this sort of a sound-based project as well, right? It's the graphics-less video game. So I quickly want to introduce you to audio. Weren't expecting that, were you? So let's look at another type in here called an audio source. So we're going to introduce another type today. And within here, it's not a 2D object. It's not a 3D object. It is an audio object, and it's an audio source. Okay. And this will allow us to play audio here. Okay. It starts off centered. It's just at the center of the scene. It's at 0, 0. It has a position in the world, just like any other object. And it, by default, will say play on awake. This is one thing you want to turn off. That means the moment it comes into existence, it plays its sound. And we don't want to do that. Now, if I press play, even if play on awake was set right now, nothing would happen because it's an audio source, but it doesn't have audio actually associated with it. Oh, and I remember I'm going to run into trouble in a moment because of the way that everything works here. I don't think you're going to be able to hear my sound. That's no fun. Well, you may have to take my word for this and try this on your own. So I'm going to go to another project that has an audio source. And what I'd like you to do is find a bit of audio on the internet. And you're going to use that as an audio source. So this is going to be an exercise. So let me see. I'm on another screen, not letting you see what's going on here exactly. Well, I'll be nice. I'll let you see it. We're not going to do check-ins because I do want this for you. So we'll go back to the internet, and if you go, you can always say free game sounds. Zap Splat. Download free game sounds. Download free game sounds here. Library of game sounds. Open Game Art is a great place to start. Okay. And let's see. We will get wet squishing sound. No. Punches. Jump landings. I'll do punches. All right. And not really hearing that. That's a whole library of them. Well, this is one example that you can go to get sounds. Now, I already happen to have some sounds on my computer, so maybe I'll just do that to make life easier. I'm going to grab some sounds. You guys are all so quiet today. You're freaking me out. Where's my simple tree assets sounds? There we go. All right. So once you find a sound that you're interested in using, it's like anything else, you can actually drag it right into the Unity asset folder. And I'm just going to put it right there. So here's bubble one, which I don't think you're going to be able to hear, but I can. And this makes it all the more interesting for the exercise. So we'll drag bubble one, which is a wave file now. I'm going to drag it and put it here in the audio clip. And if I were to press play on Awake and press start, I would hear it go, "Whoop," but you don't. Okay. But to get it to play in the game, we want to reference that audio source and play it. So similar to how we did this, we're going to get an audio source, and we'll do this. Game object, put hit sound. Okay. And what we can do with this is we have the other audio source. Cut and paste here. We had hit sound, get component audio source. And we're not going to assign it a value, but we're going to say play. So this would allow us to play the hit sound component, or the audio source component of the hit sound object whenever we hit a wall, just as an example. Now, to make this work, you have to remember that our game manager script, remember how we assigned this object here, the hit sound. Now we need to say, this audio source, let's name that something good. We'll name this hit sound. The game manager and tell the game manager about the hit sound. All right. And now, unfortunately, because of, like I said, because of Discord and everything, you're not going to hear it. That's no fun. Give that a try. Follow those steps. Because what we want to have happen in the game is we want, those sounds to be included. Now, if you follow those steps, you should certainly get a sound to play. Let's see here. Maybe I can see if I can wire this in a certain way. I don't think I can. Not in the middle of a stream. That's odd. Can someone verify that I can say something so I can definitely hear you? Okay, so yeah, these headphones are working. All right. Thank you for that. Yeah, I didn't think you could. Yeah, the problem is that it's only hearing the microphone, and for some odd reason, these weird Bluetooth headphones do odd things when I should be hearing them. I'm going to do this. Okay, this is going to be. This may be great, or this may be terrible. Let's try this. All right. Can you hear that? Okay, so you're picking up my microphone now, which is yeah, I guess this is going to work out okay. So every time I hit a wall, I get this wonderful boink sound. Move away from the wall, and I don't get it anymore. So I have a hit sound, and it's happening. The volume is set. No matter where I am, it's going to be, it's doing its thing. So I now have some feedback potentially to the user that even if they weren't able to see anything, you can imagine if they're feeling around in the room, we can start to say, okay, you bumped into a wall by giving them feedback. We can, describe certain things to them without giving away their position, right? So in the game, ultimately saying the player is at 10.3, and if they know where the end goal is kind of, that's not too exciting, right? Just saying, okay, here you have to get to the position 0, and then they can just move around to 0. That's not the most compelling game in the world. So instead, we want to do things like, well, you bumped into a wall, and they know, okay, now I have to move away from the wall, or they can kind of figure it's halfway between these two sounds, perhaps, right? You can kind of give them clues as to what's going on without necessarily giving it away. And the other, this is basically a one-shot sound that I just did here. But another thing that I describe in the game is to potentially use some type of sound that's happening all the time, right? To as a trigger or as an indication as to something going on. So what I'm going to do now is I'm going to start another audio source, and this is going to be hopefully it doesn't crash my computer. Okay, this is an actual music clip, and I'm going to have another audio source. I'm going to create here audio source, and we're going to refer to this as boombox. Now imagine that there's just some radio, some boombox that I have to find in my game, right? It's called boombox, and so it's playing music here. So I'm going to drag that on here, and I'm going to turn down the volume initially here, because it's going to, the moment I start playing the game now, play on awake is going to happen, and this sound is going to start playing. Oops, well, I was in play mode, so much for that. Okay, that's the penalty we pay here. Try it again. Audio source, and I rename it boombox, and I assign it a sound. Right, I repeat it so you learn it. Isn't that great? So I meant to make that mistake. So play on awake is set. I'm going to turn down the volume for now and hit play. You all hear that? Okay. So now the music starts playing as soon as the game initializes. So let me turn this down, this volume here. And now maybe I want to do something that's based on how far away from the player. Maybe they have to go towards that sound. So if I press play now with the sound at 0, I don't hear anything. But how would I do that? How would I say, all right, the player is moving around now, and remember I had this goal last time. I had goal X, goal Y. And maybe I make that some values. I'm not going to give it a value of, they have to get to 12, or we'll make it 11. And the Y is 3 or 2 or something. All right, so there's the goal. So if I want the sound to be continuous, the sound is already playing, and now I want to change the sound's volume depending on where the player is. So once again, I'm going to need some access to the background music. So we'll call it, this is going to be BGM for background music. And we'll go back to Unity and say, okay, we're not playing, thankfully. I'm going to go back to my game manager, and now see it wants BGM to be there. So I'm going to say the boombox is the source of my background music. All right. And now I need to sort of manipulate that somehow to do something interesting. So as I check position and collision, I could compare somehow the player's position and the goal's position. Now, it's tough for me to do this in terms of just an X and a Y, right? This is one reason why vectors are nice, right? We started talking about vectors a little bit as pairs of numbers. So you can have an X and a Y combined into a point on the screen or a point in the world. And so now if I need to compare locations, I can use these points in the world to do something quite remarkable. So here in my code, the player is moving around, and I'm going to introduce you to our friends vectors now. And this is a bit of a kludgy way to do it, but I think it'll be cool. So we'll call the first one temp player. And that's going to be player X, player Y. So I'm putting the player's position into this vector. And then I'm going to have the other one be temp goal. And in that one, I'm going to put goal X, goal Y. Okay. So now I've got these two vectors. And cool things I can do with vectors, I can create new vectors by subtracting them from one another, or doing different things to, based on their relationship between the two, right? So I could do something like have a distance vector, vector2 equals, or we'll call it vector2 distance equals, and we'll just call it blank vector for now. If I were to say, I should really call this distance vec. I shouldn't call this just distance. Equals, and we're going to say, okay, temp player minus temp goal. So that will give us a vector that points from the goal to the player, right? It's kind of the fun thing. This is between the two. I can figure out a vector between the two. And we'll go more into vectors and physics in a little bit. And the cool thing about this vector is that built into Unity, I can do things like ask it. Well, if I type it right. Things about this vector. I could say, well, what's the magnitude of that vector? How big is that? And what the magnitude of a vector is the length of the vector. Right? So this gives me a distance in between the two. The magnitude of the vector that points from one to the other. Think of a vector as an arrow for now, right? I'm creating an arrow that points from one to the other. It's always the one I subtract from this one. So this is the destination, and this is the origin of this arrow that's pointing between the two. Imagine them on a graph. And now what I want to do is I want to say, well, okay, I can do something based on that magnitude. I could say if magnitude is less than 2, now I'll do something to that audio source. I'm going to do this in sort of a brute force way, so I'm not introducing too many crazy things at once. I'm going to say change the volume of that audio source. So if it's really close up, I'm going to set it to 0.8. Else, I might set it to 0.4. And that should be what's going wrong here? There we go. So it says, okay, if that distance, the distance vector between these two is less than 2, I turn the volume up loud. Otherwise, the volume is down low. And that, well, it shouldn't be hit sound. It should be background music. Let's see how that works. What time do we got here? 4:45. We got time. Okay, good. So let's see. Now I'm going to click on Boombox here to see volume is set to 0. Nothing's happened yet. No code is run because I haven't pressed any buttons yet. But I just moved and it's set to 0.4. Notice it got set to 0.8. It got set to 0.4 because I'm further away. Maybe I want to get even more of a difference here. Maybe I set it to be else, and this is the, like I said, a brute force way to do that. Imagine a couple of different steps here. So if it's 2 or less than 2, it's set to 0.8. If it's less than 4, it's set to 0.6. Else, it's set to 0.2, or maybe this should be 0.2, 0.4, 0.6. Right, so the further away, the larger this number gets, the softer the volume is getting. I watch it in here in my code, the volume here, if I click on Boombox and I press play. So the player is at 7.3. Player's at 8.3. Oh. Okay. Now, where you go with this in terms of how you come up with a formula for this, you could come up with a function that would say, okay, based on this magnitude, based on some value that you determine to be the real range that the player could possibly be away from that object, you could turn this into a function and dynamically change that volume. All right. So when you look at the project requirements, that is what I'm referring to as being sort of a dynamic volume of an object. So you can say, okay, I'm getting louder, I must be getting closer to the object, that sort of thing. Well, right now it's dynamic as it is right now, but it's very, what we call granular. It can only be 0.2, 0.4, 0.6. But in if I wanted to be more fine-tuned, I'd probably use a function here to say, okay, for example, this magnitude, that's a number. So I could, say, well, okay, we'll see if I, just for the sake of demonstration here, let's say print not the magnitude. So once I know the effective range that I want to use there, I could write a function that said, okay, based on that magnitude, what would I set my volume to be, rather than hard coding it here? All right, so you could smoothly vary it, because watch what will happen as I run this in Unity now. And don't worry about the actual sound, but we'll look at what's happening here in the console. Right? The distance got smaller. Now the distance is getting much larger here. So what's the furthest away I can get? Well, without limitation, I could, I could probably 12 is kind of the biggest number here, right? And the smallest number was like 1. Should be 0. I don't know. At some point, I should be able to get 0. Right? Right? Didn't we say it was like around here? No, wait. Zero. So I am able to hit 0. So magnitude is 0. I know I want the volume to be set to 1. The furthest away I can get is 12. So when I'm 12 away, I want to set the volume to 0. Right? Does everybody follow that one? Okay, I was going to start typing to you. Okay, spoilers. Okay, so at 12, I want the volume to be 0. At 0, I want the volume to be 1. So what kind of formula would I use to take that range between 0 and 12 and convert it to 0 to 1, but inverted? I'll leave that as an open question for you. Volume needs to be 0 to 1 as distance decreases from 12 to 0. Right? So the magnitude is the distance between the goal and the player. So as the distance decreases from 12 to 0, I want to increase the volume from 0 to 1. So think about the algebra that you need to do to create that, to map from this range, this 0 to 12 range, to be a range from 0 to 1, and then to invert it. Do you follow does the question, or does the okay? And using that, we're always going to be using distance. Believe me, this is what we're using here is the simplest form of collision detection, for starters, and we're going to do something based on that, right? In games, it's going to get much, much, much more complicated with regards to collision detection. But ultimately, you detect whether or not you collide with something based on some sort of distance metric between you and, or the player and whatever it's colliding with, or between two collider components, right? So we have, in this case, we have this artificial there, and they're just really just 2 points. We have the point that the player's at, we have the point that the goal is at, and then we use a vector that is the distance. Now, what a vector has, it has a distance and a direction. We're not doing anything really based on the direction of the vector just yet. We're just using the length of that arrow, the length of that vector that points from the goal to the player. We'll talk a lot more about vectors in the future. Right. So that's the exercise. Any questions? Now maybe I'll really try to do something in Bolt. I wanted to show off audio sources and some of this dynamic stuff, since that's part of the project. Bolt is sort of the optional part of things. Whether you decide that you want to use Bolt or not, that is sort of up to you. You can choose to do more things in Bolt and less things in C# and vice versa. But let's give it a little bit of a try, if I can. All right, so nothing really changes. Bolt can be just another thing that's in your scene. It's just, instead of having a C# script that I add to a component, I can add Bolt graphs to things. So we had our game manager here, and the game manager had a script on it. So what I'm going to do is I'm going to take that game manager and I'm going to add a component that is a Bolt component. I'm going to add that on there as well, just to sort of demonstrate Bolt and some of its constructs. Okay. There's two types of things, two main types of sort of scripts that Bolt can run. Bolt can run a flow machine or a state machine. We're going to start with flow machines. They're more just like a straight script sort of thing. State machines are a little bit trickier. We'll leave that for another time. So I have already installed Bolt, so you have to add it as a package or add it as an asset. So if you have to go to the asset store, agree to download it, and then once it's there, if you use your package manager, so you'll see in here, tools, let's see, no. Package manager. Oh, can I still get to the asset store? Maybe I can. Okay. So normally you would go to the asset store and download Bolt. These days now, because it's changed, you have to open this in another window, go to the asset store, buy, quote unquote, for free. You can buy Bolt. And then come back here and you can install it using the package manager. So you can see here, these are the packages that I have. And somewhere, if I load the next 25, I think it's probably going to show up. There's Bolt, right? So I have Bolt already as an asset that I have bought in the asset store. And then I can choose to import or download if I need to. If I haven't downloaded it yet, I download it from here, and then I can import it into my project. If I hadn't already, I could do that here. Okay. So follow the basic instructions. The instructions for Bolt on Unity's site to get it installed. If you run into issues with it, let me know, and we can kind of go into more detail on that as well. But for now, I'm going to assume that you've got it installed. And this is really just a 5-minute whirlwind tour, so don't necessarily follow along on this one. You're going to want to take your time through this a little bit more. Then I'm going to go relatively quick with this one. But just to show you how crazy and zany it is. No, sorry. How different it is, or give you a little bit of a taste of it here. So I'm going to add a component, a Bolt component, which is a flow machine. So this is the equivalent of adding a script. So I'd add a flow machine. And when you add a flow machine, now we have the option of making it a macro flow machine or a embedded flow machine, right? If it's embedded, it is unique to this game object that it's on. If it's a macro, it winds up being something that's going to be available to other objects to use. So most of the time, you can say, go ahead and we'll make it a macro. And in order to do that, we have to say a new macro. It's going to ask us about a name. And I'm going to go ahead and create a folder called bolt macros. And we'll go to the bolt macros, and we're going to name this one manager, I guess. Manager. There we go. Manager. Save. Okay, so you see I now have a manager flow machine here, sorry. Right. Really can't see it. It's not really much there. I mean, we can put a title on it. We can put a summary on it. A lot of these things are sort of optional, so we don't have to actually have that. But the important thing is we're going to say edit graph. And this will pop up usually on another monitor, which is why you guys can't see it right away. So I'll put it down here so you can. So the most basic part of a flow manager is going to look remarkably similar, or remind you, hopefully. And actually, let me close this and open this again here. Edit. I'm mad that it kind of hid that other part over here. Let's see. Can I increase it? It's not going to snap back. All right. Well, we'll leave it off for now. Come on, Bolt. Behave. There we go. That's what I wanted it to do. I wanted to get rid of this, though. There we go. All right. So much like a C# script, we have a start and an update. So feels a little bit like a script. So we have something that's going to happen when start happens and something that's going to happen when update happens. Right? The difference being that we're going to have this visual flow, which is why it's called a flow machine or a flow macro, as opposed to linear code execution. Right? So we see this little green arrow, which is the flow of execution. Right? Think of that as the flow of execution. So something is going to be connected to these things to trigger when that event happens. So imagine I wanted to print something. So I'm going to add a unit. So instead of just typing function names, I add units. Units are sort of like the different components, sort of like different functions. And we can just start kind of typing into this field here to say things like, whoops, print, for example. And you will see, we have monobehavior print message. Logs messages to the Unity console, identical to debug.log. Wonderful. There it is. So I want this to get called when start happens. Okay, so I set up a chain. I say, okay, monobehavior print. Start event should trigger a monobehavior print. And now I need it to print a message. So the question is, how do I print that message? Well, I need to give it some other bit of information. And that's, you'll see here, this little dot is going to say, okay, I need a variable. I need some more data to go into here. So if I right click and say add unit again, I know normally what do I do with print? I print a string. So I'm going to type string. And I can see there's lots of different potential strings I could work with here. And I can see all of even the different functions that I can get run on a string. But for now, the single thing that I'm going to use is I want to just a literal string, because that's all I want to do is I just want to print out something here. So I'm going to look for string literal. And inside of there, I can say, hello, Unity from Bolt. And lots of exclamation points. So now I have a string. This is the equivalent of saying string something and giving it something to print. And I want to connect that up to this message. So now I have the equivalent of typing in print inside the start event in a C# script. So if I come over here now to my game, and maybe I'm just going to shrink this down a bit. And you can dock this in here, so we can kind of dock that in. I'm trying to scroll here. Scrolling. Oh, there we go. I forgot. Scrolling is a middle click. Up here, I'm going to press play and go to the console. And I'm going to get lots of object references not set there. Why is that? Do on GUI. Well, I got my hello Unity from Bolt, so that actually happened. So it did what I wanted it to do, but it did all these other great things. These other not so great things. And it's continuing to do them over and over and over again. All right. Let's take a look at our... Yes. You know what it is? It's this thing here. I don't know why that is. This is actually an interface. Notice it's complaining about interface errors. So yeah, maybe I should update to the latest version of Unity. I'm going to do this. I'm going to say save. And I'm going to quit Unity because I don't like this box that was hanging around doing nothing. So you can see my process of what I do when things start freaking out. And I'm going to reopen Unity. And this is the problem with beta software, I guess. The latest version, not quite the latest version of Unity. All right, we're back. And our state is still where it should be. Let's go to our hierarchy. We can see our game manager. Click on that. There's our inspector. There's Bolt, now sort of hopefully behaving. And there's our console. Everything's good. Press play. Hello, Unity from Bolt. And it did exactly what we wanted it to do. Whew, much, much, much better. All right. So this is contrasting, how do you like to code, right? Do you prefer this? This sort of thing? Or, are you a quote unquote, do you believe that you are a visual programmer, someone who likes to see this sort of thing? It's interesting. I think there's like sort of certain circumstances. Oh, Bolt, behave now. All right. It's complaining that certain things aren't necessary anymore, but I have updated. All right. So certain types of operations, and you can mix and match, like I said. So now already we've got a script on this object, and we have a Bolt flow machine on this object, and they can even talk back and forth to one another. Like say if I wanted to, I could even, if it behaves, add unit, and you see game manager here. I can look at certain game manager objects. So let's see. I could find a component of that game object. And game object get component. We'll look at, see how crazy it gets. We'll look at the, itself, which is the game manager. That's okay. And I'm going to look for my other component, which is, it's my script here. So I'm going to look for game manager script. And then I could query information about that actual game manager script if I wanted to. So it is very powerful, and you can kind of go back and forth. But the key with Bolt is probably, start small, work your way up. And let's see, I think we're 5 after 4. We're doing okay. Without diving too much more into Bolt, because we haven't, there's a lot of these things are going to be at much deeper levels, but you'll find that there is even ways to do ifs. So if I wanted to do a if in here, or let's see, no, it would be inside of control, for example. In control, I can have switches, I can have branches, I can have for loops, I can have while loops. So I might have a branch here that changes execution based on whether or not this is true, right? So here's a good, for example, let's do an if. So this print happens, and then after that print, I'm going to run this branch here, and this takes a Boolean here. So I'm going to say add unit bool, and I'm going to have a bool literal, which is set to true. And maybe I have another print statement. So, and I have another string literal, maybe even another string literal. If nothing else, it's fun to program in Bolt, sort of. So I'll say, here's this message, and that's going to be the true message. So let's see here. I'm going to put this together, and we'll take a look at how it worked here. So this is my true code, and I need to have my false code. So I've set it to true here. So then that should say, hello, Unity from Bolt. And then go through here, say, this value is true. So do this. Let's see what happens. Sure enough, hello, Unity from Bolt. Boolean was true. Are all of your heads spinning and going, oh my gosh, why would you ever want to use that? It is. It actually is. And so you can do, any form of calculation. You can do math. You can do, all sorts of great things. It's very similar. The reason I kind of stress it and really want to do it is that Unreal relies quite heavily. The Unreal Engine relies quite heavily on its blueprint system, and that the blueprint system is also a visual scripting language like this. Whether or not Blueprints is has been around or been kind of more tightly integrated with the Unreal Engine for a little bit longer, whereas Bolt is now becoming sort of more officially part of the whole Unity ecosystem, where it used to be from another company. Now it's becoming something that Unity as a company is supporting. So I think it's going to become more and more powerful and kind of more and more mainstream, and hopefully not as many of these weird little errors and things like that. But for those of you who just, if you really just want to whip something together, you can imagine it's, pretty straightforward once you get the hang of it, to like little messages like this, or the state machine stuff is particularly interesting, and we'll see if we have time to kind of get into that whole bit. But even imagine if I wanted to give you another example of a for loop. Okay, let's do a for loop. All right. So you'll see it's all set up nice visually here. And now, let's see. It's always a matter of continuing on from the last bit of code, right? So now after it does this, it's going to trigger this, right? It's flowing through here. And the moment a box is triggered like this, it kind of slurps up whatever it needs to from over here. If there's not, already something present, like here, it does have defaults. But if it's not something, if it needs to calculate something and it's connected, it'll kind of back trigger some of these things as well. So here we have a first. So it's I is 0, last is 10, and step by 1. So this is very similar to that exact loop that we had before, which was, for I equals 0 to 10, and it printed something. So let's do this. Let's grab another print and say each time it runs, it's going to do this. But now we have to get a little tricky and we say, okay, this index here, how do we turn that into a message? Now, the naive way is to just go ahead and plug it in there, and we're just going to get the number. So if I press play, we should see the number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you can do loops in Bolt this way. If I wanted to have a message that kind of had that in there, I would probably need to get a little bit trickier and add unit. Let's see. I could use string into string, string splitting, string joining, and so on and so on to kind of build up a string if I wanted to. New string, and it would pass this to here, and that's what would get passed, and this would be here, and I'm not used to building strings. Normally in you're not normally not processing a lot of strings and things with this. So normally it'd be like, okay, create 10 enemies or something like that. I'm not as familiar with the string stuff here. Let's see. A lot of the time you can just drag something out and let go, and it'll give you some ideas saying, okay, what should you be putting into there? So mathematical formula, variables. I'm going to leave this. Maybe I'll have more of a demonstration. Oh, here's where I ran into trouble last time. Okay. Didn't blow up things. Uh-oh. Oh, no. The fuzzy window is complaining. All right. We're at 4:15, which is plenty of time. And I did skip over the check-ins today because I wanted to at least start to show you the possibilities, first off of, with audio, because that's going to be a big part of your project. And then secondly, to whet your appetite with regards to Bolt, and to show you that a lot of the same things, and certainly this type of stuff we've done so far, with basic structure like for loops and printing, and even use of strings and booleans and so on, are all possible. And you can, of course, do things like reference other game objects. Like, so there was a game object. Or let's see, can I grab an audio source? Audio source. Well, in 5 minutes, I'm not going to be able to do that. But you can get access to any of the objects in there just like they were in any other script. Ultimately, it kind of compiles back down to the same sort of thing, and it runs fairly efficiently as well. You can do all sorts of kind of cool debugging and watch the program flow and so on in there. So it'd be fun to kind of contrast those. So do me this favor, if you are particularly interested in Bolt, kind of, I'll do a little poll over there to see how deeply folks want to get into Bolt or not. But we'll kind of wrap it up there. Unless any questions. So for the weekend, the idea is to continue thinking about the project. Refer back to the last lecture. At the very end of the lecture, it had the requirements and stuff about the project. Continue, kind of integrating the audio source in there, and come up with a plan for your project, and then ask me any questions about going forward with it. When is it due? That's a good question. That's always a good thing. I'm going to probably issue an extension on that. So it's not going to be like months of extension, but I think it's going to be at least it shouldn't be. I think it should be the 30th. It should be at least 1 week extension on that one. Yeah, it's. I guess I was a little optimistic on things, and especially this last summer when we had intro to game programming over Arch, which was all basically juniors and seniors. So as you can imagine, they kind of jumped in with a lot of background programming kind of stuff. So we kind of compressed the schedule because Arch is also only 14 weeks instead of the full semester, and so on and so on. So we will definitely have the time we need. But between printing things out dynamically and triggering audio sources to play and to vary the sound dynamically, that's the bulk of it. So you really kind of have more or less everything you need to kind of create this sort of, I don't think there's anything that's left out with regards to the requirements. So if you can have audio sources, dynamically vary them, move things around in the world using your interface and buttons, and the kind of the core thing of modifying text on the screen within a UI object. So don't underestimate how much you already know now, hopefully. Okay? All right. On that note, have a great weekend. Do reach out to me. I'm around. I'm on Discord all the time, in case you haven't figured that part out yet. I've gotten a handful of invitations to specific projects, but not nearly, even though your projects are not full-fledged yet, or some of them maybe even just be empty Unity projects, you should be inviting me to be a member of your organization and invite me to collaborate on the specific projects that you have. So let's try to get that worked out. Usually, okay, I'm going to post a video over the weekend that explicitly kind of goes through that whole thing kind of step by step. Okay? That's something I can do as a... if you think you have already invited me to an organization and invited me to a project, shoot me a direct message just so I know. Actually, you know what? I'm gonna post a poll because I'll be able to see who has done it there, and then I'm gonna double check through there. All right, just to kind of let everybody off the call for now. All right, I'll follow up with you all via that. Any other things to trigger my brain with? The basic requirements, it is in the lecture notes from the first part. I'll pull that out and make that a separate document so you can just find that in, without looking through the other one. I'm going to revise everything again today. So streamlining things. All right. Thanks again. Have a great weekend. Stay out of trouble or have fun, but stay out of trouble. These days it goes without saying. All right. Take care. Bye-bye.